Okay, we're going to talk about the evolution of the Earth's atmosphere. And if we look over here, you can see this is the composition of the atmosphere today. So, and we've got about 80% nitrogen, 20% oxygen, and you notice these don't add up to 100 because I'm saying approximately. About 1% argon, noble gas, and about 0.03% carbon dioxide. And of course, that's rising slightly. Okay, so the oldest rocks on the Earth are about 4.5 billion years old here, and this is where we're going to start looking at the Earth's atmosphere. So you can see early on there was a lot of water and a lot of water vapor, and that dropped, and it got down to very low levels here, and that was due to the temperature of the Earth dropping and the water condensing to form oceans, and so it becomes liquid water rather than gaseous water. Right, we can see the red line here that shows the amount of carbon dioxide. So the and this part here up to you can see the levels of carbon dioxide rising, and that was due to volcanic activity. Okay, so what volcanoes throwing out an awful lot of carbon dioxide, and the volcanic activity in the Earth's history, the Earth's early history was much greater than it is today. Now we can see carbon dioxide levels reaching a maximum around about here and then starting to decrease. Okay, so what processes were responsible for the decrease in carbon dioxide? Well, before we think about photosynthesis, what was probably more important in terms of the mass of carbon dioxide you've removed is the formation of carbonate rocks. So in the Earth's early crust, there were metals, particularly magnesium and calcium, and you get reactions to form calcium carbonate, which is limestone basically now, and magnesium carbonate also present in limestone. So vast amounts of carbon dioxide was turned into these, and it's important to realize that there's a misconception sometimes that the carbon dioxide is trapped in bubbles in these rocks. It's not. If you look, there's the elements carbon and oxygen are actually present in the compounds which form the rocks. Okay, so we've got a lot of carbon dioxide taken out of the atmosphere being turned into carbonate rocks, and that is, people tend to forget about that when they answer these questions about how the Earth's atmosphere has changed. What would also be important here would later on would be the evolution of photosynthetic organisms. And of course the equation for photosynthesis would be you've got carbon dioxide and water, 6 waters, goes to form, well, initially glucose and oxygen, 6 oxygens, and then of course that glucose would go on to form biomass. So that would be taking some carbon dioxide out of the atmosphere. Now the in the Earth's early atmosphere, say, it wouldn't be higher plants, it would just be literally would be photosynthetic bacteria, and then higher forms of plant life would then evolve. Right, so we're getting photosynthesis occurring here, and you may think, well, why isn't the level of oxygen going up at that point? The level of oxygen didn't seem to increase till a lot later, okay, when you got appreciable amounts of oxygen. Right, and that was because at first any oxygen which would be produced during photosynthesis, of course, there would it reacted with iron. There's a lot of iron in the Earth's crust, and it reacted with the oxygen to form iron oxides. And it was only when all that iron had all been used up that then the levels of atmospheric oxygen could start to rise, as we say, getting up to about the 20% that we see today. Okay, so that oxygen rise is entirely due to photosynthesis. Right, let's just have a little think about any biomass, which so we get carbon dioxide here being taken in by by photosynthesis, turn into glucose, and then converted into biomass. Now, that may then go on to form fossil fuels, oil and gas and so on, and coal. But a lot of it wouldn't have done it. You get the carbon cycle where a living organism dies and it decomposes. You have decomposing organisms, which will turn that biomass back into carbon dioxide. Okay, but undoubtedly, yes, some of it was trapped as fossil fuels, as we know, because we still dig up fossil fuels and use them now. We just have a quick look at the oxygen levels as well here. So I can see that it got as high as about 30% at that point there, before dropping down to the levels of oxygen that we have now. And interestingly, that at that point here, in the fossil record, you get insects, very large insects, like dragonflies with 2-meter wingspan. Insects now, because we've got 20% oxygen, there's a certain size that they can't get above that. They don't have lungs, so they're not very efficient at extracting oxygen out of the air, and they rely on diffusion, and so they can't get above a certain size. Of course, when the oxygen percentage was higher, they were allowed to get bigger. Also, interestingly, when oxygen became predominant in the atmosphere around this point, a mass extinction of mostly microorganisms occurred then. A huge mass extinction, because all of the life on Earth had evolved to live in an oxygen-free atmosphere. Oxygen's quite a strong, it's an oxidizing agent, it's reactive, and so they hadn't evolved to cope with that. It was toxic to them and killed them. Okay. What we haven't talked about here so far are the levels of nitrogen, okay, which is now around about 80%. And it hasn't changed that much. I think it's increased slightly, I think mostly because the amount of the percentage increase of nitrogen, not because there's more nitrogen, but there's less other things like the carbon dioxide has been taken out of the atmosphere. In the Earth's early atmosphere, there would also be the ammonia gas, NH3. As soon as oxygen came around, that would be oxidized to nitrogen. So there's no ammonia in today's atmosphere. And of course, any nitrogen that does form tends to stay there as nitrogen, because nitrogen is very unreactive, which is that very strong triple bond between the nitrogen atoms, very high activation energy, so it doesn't do much. Okay, so that's the evolution of the Earth's atmosphere from about 4.5 billion years ago to today. And the main thing you have to realize is the amount of carbon dioxide has gone down. Don't forget, it's not just due to photosynthesis, it's mostly due to this formation of carbonate rocks, and people do tend to forget that. Other questions they ask about this, they quite often ask you to look at the atmosphere of Mars and Venus, which still have a lot of carbon dioxide and don't have any oxygen. And of course, that's because photosynthetic life has never evolved on those planets, so you get no oxygen and you just get an atmosphere of carbon dioxide.